2. For step 2, what are we trying to find for step 2? That's what we do, but what is it that we're going to be getting by doing this? The vertical asymptotes, right? Now, I get tired of writing vertical asymptote, vertical asymptote, vertical asymptote. It's kind of a pain in the ass. So I do V dot A. Is that all right with everyone? Can we all understand that means vertical asymptote? All right. To do this, I set the denominator equal to 0. And I hope that you recognize this. Do you? It's difference of squares. I could rewrite this as what? X minus 3, x plus 3, and you can do it the other way, right? Either way. And now you set each of those equal to 0, don't you? So I set x minus 3 equal to 0. X plus 3 equals 0. And solve both of those little linear equations. Just isolate your x. So what are the two answers you get for this? 3 and negative 3. So the reason why in the previous one, see what I wrote down here in red? Points on the x-axis. The reason I did that is because if you just look at this, 0, x is 6, x is 3, x is negative 3, you might like lose sight of what these are on your graph. What are these? Are they points on the x-axis? No, these represent vertical dotted brick walls, right? That's what this is. So I'm going to put here, these are vertical dotted or dashed, however you want to say it, dotted lines, right? That's what those are when I draw them, vertical dotted lines. These are not x-intercepts. These are x-intercepts. These are not. Now step 3, which I said is the most confusing. We are trying to find in this step what? The horizontal asymptotes. I'm going to write H dot A dot for horizontal asymptotes. What do we do to find the horizontal asymptotes? Leading coefficient? Okay, why are you doing leading coefficient? There were 3 cases, case A, B, and C. How do we determine? We compare their powers. Okay, so what is the degree of the numerator? The degree of the top is 2, right? So I can say it this way. The degree of the top is 2. What's the degree of the bottom? Same thing, right? So when we compare these, if these two are the same, we're in case C. Case C. Does anybody have any questions on how I determine we're in case C? No? Since we're in case C says y equals the leading coefficient of the top. What's the leading coefficient of the top? 1. What's the leading coefficient of the bottom? 1 again. I just made this is our first problem, so I made it nice and everything's going to work out clean. This is 1 over 1, which is just 1. Now, can you describe to me, so I can write it down here, what this is when I draw it? It's a horizontal dotted line, right? That I draw at the ends. This is important. At the ends only. I'm going to state that right here. Actually, I'll put it up here so you can see it. This right here are horizontal dotted lines at ends only. Remember, this horizontal dotted line came from the fact that the longer you live, less probability you're alive, right? It doesn't, that horizontal asymptote, where you're headed, has nothing to do with what's happening in the middle of the graph. So your horizontal thing only exists at both ends, not in the middle. All right, let's draw it. We have about 10 minutes. All right, here we go. I'm going to draw an x and y axes first. X, Y. There we go. This is step 4. I'm putting all the information, right? That's what step 4 says. Plot all the information from parts 1, 2, and 3. So let's start back here at x-intercepts. I'm going to place points onto the x-axis at 0 and at 6, right? So I'm going to go to 0 here, put a dot. I'm going to go out 1, 2, 3, 4, 5, 6, right here. I'm going to put a dot. Good? This next step is the most important thing I'll tell you ever. Ever. No, she didn't hear me. Sorry. All right, so we got that, x-intercepts. Now what? Vertical dotted lines. So make sure at 3 and -3 that you do not come stick points here. That is going to confuse you. Make sure these are only vertical dotted lines. And you know, you can use a ruler or whatever, just sketch them. And there's 3, right? And I come out here, dotted line, like this. Okay. I'm using red just to stress that that's not part of my graph. It's just a barrier. Brick wall. -3 is over here. Here's 3. I draw another one of these. All right, we're getting there. One more thing. Horizontal, which is going to be a horizontal dotted line that I draw only at the end of my graph, but it's going to be y equals 1. So here's y equals 1. Everyone agree with that? That's y is 1. So I need to have a horizontal line that's this high off the ground, but I only draw it at the ends of my graph. So I'm actually going to kind of exaggerate this. I'm going to come out here, I'm just going to draw a horizontal thing like that. And then over here, about 1 unit off the ground, just kind of out here towards the edges. Y'all see it? Okay. We're close. Believe it or not, we are really close to having this. Here's why we have to do these things test points. Do y'all see that's the next step? Test points? Here's why we have to have test points. As it stands right now, there are a lot of ways that I could draw this. All right? And there are a lot of ways that you could draw it where we don't cross the barriers and we all have good graphs, but they're different. I'll give you an example. I could do this. And then over here, I could do that. So does that do everything it's supposed to do? Let's check it. Does it start to go towards this dotted line as I go out? Okay, when it comes towards this barrier, does it force itself up? Yes? Okay, over here, does it cross through the x-intercept? Yes. As I go this way, the barrier forces it up. As I go this way, the barrier forces it down. That all looks good? Over here, does it cross through the x-intercept? Sure, right? Goes down, that's good. Does it flatten out towards that? So that all looks good to you, right? But I could also draw it a completely different way and it would still satisfy it. So let me try this. This I may not be able to get around. I might have to just continue this again. So if I did this, that's still good. But what about this instead? Would that one in purple still do it? Yes? And over here, how about this? Bounce off that and go back up. Would that still do everything it's supposed to do? This is going like that, that's going like that, right? Okay, touches the x-intercept, dives down, goes up. Yeah? So I'm still good. Over here, does it touch the x-intercept? Yes. Going this way, follows that up. Over here, does it flatten out towards that? Yes, so everything I drew in purple it could be that one, or it could be the blue one, or someone else might be able to draw something else in here. So this is not enough information. Just what we had up there before is not enough, which is why the next step is test points. Do y'all kind of see what I'm saying? We need more points in order to narrow down which of these graphs it is. So how many test points do we need? Seems like we might need a lot, right? It turns out, pay attention please, it turns out that you need to just count up how many x-intercepts you have and count up how many verticals you have. So how many x-intercepts did we have? 2. How many verticals did we have? 2. We're going to need 5. One more than that is what we'll need, okay? So if we have 4 total x-intercepts and verticals, you'll need 5. If you had 3 x-intercepts and verticals, you would need 4, right? So it's always one more than the total you have. But where do I pick them? So I'm going to now get to this step. I'm going to write it over here. I'm going to do test points. I might actually not be able to finish this. Test points. I'm going to need 4. Okay, one more than total x-intercepts and vertical asymptotes. Understand what I mean by this? You'll always need one more than the total number of x-intercepts and verticals together. I had 2 verticals, 2 x-intercepts. Yes, I need 5. Sorry. Thank you. All right, so where am I going to get them? What you're going to do is you're going to start walking along the number line until you, okay, so everyone start on the left side. I want you to start moving along until you hit your first vertical or your first x-intercept. Doesn't matter which one happens first. So ready? Right there at what? -3? Okay, right there, -3. You have to pick anything you want to the left of it. Anything, doesn't matter. I heard -6. Put a little X there, not a dot. Notice, this is a dot. I'm putting a little X there as a marker. I'm going to be testing -6. Okay, so that got me up to -3. I picked something to the left of it. I also need something to the right of it. So pick something to the right of it. But don't go past this right here. Something in here. -1. You could have used -2 also. Little X there, marking it -1. Okay, so I have something to the left of it. I have something to the right of it, don't I? Now, look at this x-intercept. Do you have something to the left of it? Yes, -1. Do you have something to the right of it? Not yet, so give me something to the right of it. 2? Could I have used 1? Yes. Okay, so 2 is going to be another test point. How many do we have so far? We have 3? Okay, we need 2 more. So look at the next one, 3. Do I have something to the left? Yes. Do I have something to the right? What do you want? 5. Okay, then go to the last the last piece here, last x-intercept, 6. Do we have something to the left? Yes. Do we have something to the right? No. So give me something over here. 8. There they are. 5 test points. So the way I could say that, and it's hard to say it like with English, is that you need a test point on each side of every x-intercept and vertical asymptote that you see. You need one test point, at least one on each side. Okay? And now guess what you get to do with those 5 test points? Plug them into the original function and see what you get out. So you're going to have to plug in -6. You're going to have to plug in -1. You're going to have to plug in 2. You're going to have to plug in, I'm going to run out of room. What else? 2, 5, and 8. 2, 5, and 8. Do you not like these already? It's a long problem, right? So you get to plug those into the original function here. So let's start with, I'm out of time. Let's start with -6. Do y'all understand what you would do? Okay, since we're out of time, here's what I'm going to do. I'm going to leave you as homework to finish this out. I want you to go, plug these values in, get a nice graph together, plot those points, and see from the plotting of the points if you can draw it. That's all you need. Once you have those points, that's all the information you need. See if you can do it on your own. We will come back and we will continue by graphing some more, and after we've done a couple of these, I'll send you home with some to do. So your only homework tonight is to plug these in and kind of review the problem before next class. Everyone have a great day.
When's your birthday, sir? When's your birthday?
August 31st.
How was your Halloween thing?
It was great.
Did like a haunted house, right?
Yeah, it was great. We had a pretty good turnout. Lots of kids, scared of lots of kids. So.
Is this sucks since a lot of them did it earlier since they have school the next
Yeah.
day? So it ended at like 8:30.
Ours went till probably about 9:30, I think, is when we finally shut it down.
Did you dress up?
I was a couple of different things. Yeah, I like changed because I don't know. I just changed.
Why not?
Yeah, I was a clown, and then I was some other thing. But I was in my garage. I was like in my house. I'm not wandering the
They
street.
don't know if it's your house or not.
Well, I wasn't wandering the streets as a clown. That would have been kind of foolish.